Now, we will see the another problem. Point charge Q1 300 microcoulomb located at 1 minus 1 minus 3, 1 minus 1 minus 3 experiences a force F1 bar is equal to 8ax minus 8ay plus 4az. This is the force experienced by that particular charge. That means our test charge itself is Q1 only. Q1 is experiencing that force. Q1 is equal to 300 microcoulomb available at 1 comma minus 1 comma minus 3. That means it is the observation position, and it is having the force that is already they have given, that is 8ax minus 8ay plus 4az. What is the cause for that one? What is the source for that one? Means Q2. Source charge is given by Q2, that is available at 3 minus 3 minus 2, but they did not give the value of the Q2. That is what we have to find. Force value they have given. So, one is unknown thing, that is Q2, that we can able to observe here easily. So, F1 bar is equal to, I am writing the formula first. They have given F1, so I am also taking F1 only. F1 bar is equal to 1 by 4 pi epsilon Q1 Q2 by magnitude of R12 whole cube into R12 bar. So, what is the R12 bar? First we will calculate that one. R12 bar is equal to observation minus source. So, observation point is 1 minus 1 minus 3 and source point is 3 minus 3 minus 2. So, observation minus source we have to perform. So, 1 minus 3 is minus 2 ax cap, minus 1 minus of minus 3 is plus 2, that means plus 2 ay cap, minus 3 minus of minus 2 means minus az cap. What is the magnitude of R12? It is equal to square root of 4 plus 1, that is root 9, that is 3. Now, substitute in this particular formula. F1 bar already they have given, that is 8 ax cap minus 8 ay cap plus 4 az cap is equal to 1 by 4 pi epsilon is nothing but 9 into 10 power 9. Q1 is 300 microcoulomb and Q2 is, that is what we have to calculate, by magnitude of R12 cube is nothing but 3 cube, that is 3 into 3 into 3 we am taking, and R12 bar is minus 2 ax cap plus 2 ay cap minus az cap. So, like this we have taken. So, now just simply calculation we have to do. 3 3s are 9, here also 9 is there, 3 1s are 3, 100s are 300. So, like this we have taken. Okay. So, what we are doing in the sense here, 8, I am writing the vector like this, 8 minus 8 4 is equal to, now here what we have, 10 power, this is 11 and it is 10 power 5 we will get, 10 power minus 6 means. Okay. So, into Q2, and here I am writing minus 2, 2 minus 1, and this 8 minus 8 4 I am writing as, if you take minus 4 common here, minus 2, 2 minus 1 will get, that is equal to 10 power 5 into Q2, here minus 2, 2 minus 1, and what we can able to write here, minus 4 is equal to 10 power 5 into Q2. So, this thing we can able to get Q2 is equal to minus 4 by 10 power 5, that is equal to minus 40 microcoulomb. So, like this we have calculated Q2 value. Next problem, it is required to hold 3 point charges of q coulombs each in equilibrium at corners of an equilateral triangle. So, one equilateral triangle we have to take. So, this is x axis, this is x axis and this is y axis, and equilateral triangle is represented with that red color, and we have 3 charges, 3 point charges of q coulombs only. So, here q coulombs is there, q coulombs and q coulombs. We will assume that the equilateral triangle side length is a, small a. So, that we will be having here this length is a, that means q, this particular corner or vertex of this particular triangle is available at 0 0 0, and this particular charge is available at a comma 0 comma 0, because this side length is a. And what about this one? Here in the middle we will be having a by 2. So, the x coordinate for this particular charge is a by 2 comma, what is the y coordinate? Here we can able to assume what right angle triangle, this part I am taking, this length is a, because that is the equilateral triangle, every side is a only, and here we have a by 2. Using the Pythagoras rule, what is the side length of this one? That means how to get that one? Square root of a square minus a square by 4. So, you will be leaving with the root 3 a by 2. Okay, this length is root 3 a by 2. So, root 3 a by 2, this is the thing. Next, we will continue the problem. What point charge is to be kept at the centroid of the triangle, so that the charges would be in equilibrium? So, here this is somewhat different problem. What is meant by equilibrium means the total force on the charge is equal to 0 due to the remaining charges. So, here they are asking to calculate the charge which is to be kept at the centroid of this particular equilateral triangle. If you keep that particular fourth charge, already 3 charges are there, those 3 charges values are also same, that is q coulombs only, and fourth charge we have to keep at the centroid of that particular equilateral triangle. If you keep that one, what will happen means at these 3 charges the total force is equal to 0. Okay. So, I am taking this is the first charge which is available at origin, second charge on the x axis, and this is the third charge. Fourth charge we have to keep at the centroid. What is that charge that we need to identify? So, that charge I am taking as q dash, that q dash we have to write in terms of the q, that is what they are asking. So, for the equilateral triangle there is a rule, that is the centroid is at here, centroid is actually dividing this particular line in the ratio of 2:1. Okay. So, here what we will get in the sense 1 by 3 we have to multiply this root 3 by 2 a is multiplied with 1 by 3. So, what we will get 1 by 2 root 3, a by 2 root 3 will get. Okay, centroid is dividing this particular line in the ratio of 2:1. So, that we need to multiply this root 3 a by 2 with 1 by 3. So, we will get a by 2 root 3 will get. Okay. So, this length is a by 2 root 3. So, the coordinates of this particular charge q dash are given by x coordinate is a by 2 only, but y coordinate is a by 2 root 3. Now, 4 charges are there q, q, q at the vertices of the equilateral triangle, and fourth charge q dash at the centroid, and all the coordinates we have, and q1 only, sorry, q dash only we have to calculate. Okay. So, I am calculating f1, that means for the first charge I am calculating which is available at 0 0 0. f1 bar is equal to, I can take this q dash is the fourth charge, I have to calculate f41 bar plus f21 bar plus f31 bar, it must be equal to 0. If it is 0, then only I can tell the charge available at origin is in equilibrium. You no need to take charge which is available at 0 0 0 only, you can take the charge at a 0 0, or you can take the charge at a by 2 comma root 3 a by 2 also. These 3 charges will be in equilibrium because of the fourth charge available at the centroid. I am taking at origin, charge available at the origin. So, to calculate f41 we need r41, r41 bar is equal to, again same thing, observation minus source charge So, 0 minus a by 2 is minus a by 2, comma 0 minus a by root 2 root 3 is minus a by 2 root 3. What is the magnitude for this one? Magnitude of R41 is equal to square root of a square by 4 plus a square by 4 3 is a 12. So, it is equal to square root of 4a square by 12 we will get. Okay. So, it is equal to 2a by 2 root 3, that is equal to a by root 3. This is the R41 magnitude. Similarly, R21 bar is equal to, so R21 means position 2 is the source and position 1 is the observation. So, observation minus source, 0 minus a is minus a, 0 minus 0 is 0. Here we no need to deal with y coordinate, that is why only two coordinates are enough, x and y. So, what is the length of this one? You no need to calculate this one directly, because that is one of the sides of the equilateral triangle, that is a only. Okay. Then R31 is equal to, position 3 is the source position, position 1 is the observation position. So, observation minus source we have to perform. Okay. That is 0 minus a by 2 is minus a by 2, comma 0 minus root 3 a by 2. So, minus root 3 a by 2. You no need to calculate the magnitude, because that is one of the sides of the equilateral triangle, that is a. If you calculate also you will get a only. So, we have distance vectors, then we are ready to calculate the force. We have to make that force is equal to 0, then we will get here q1 q dash in terms of q. So, F1 is equal to, so in all the three forces we will be having 9 into 10 power 9. In all the three forces we have the test charge, that is q. So, q is also common. Now, first one is F41. F41 is nothing but due to q dash. So, q dash by, what is the R41? A by root 3, cube we have to take, that means a cube, and here you will be having 3 root 3 in the numerator. Next, what you need to write? Vector you need to write, that is minus a by 2 comma minus a by 2 root 3, this is the vector we have, this is the first force, plus in the second force you will be having another q, because source is also q only, test charge is q, source charge is also q only, that is why I have written here q. Next, by magnitude of R21 is a, so a cube directly will get, and the vector is, distance vector is minus a comma 0. Next, third force. In the third force again the source charge is a only, sorry q only, q I am writing, and distance is a, so that is a cube, and then vector is minus a by 2 comma minus root 3 a by 2, this is the thing. Okay. So, like this we have, but this entire force is equal to 0, because the charge q available at 0 0 0 is in equilibrium. Then we can take this entire thing to the right side. So, we will be having like this only, 0 only, this entire thing is equal to 0, and we can take here a cube is also common. So, you will be leaving with the numerators only. So, the force is equal to 0 means the x component of the force is 0 and y component of the force is also 0. You can take x component or y component. I am taking now x component is 0. So, the next equation will be like this, minus a by 2 q dash 3 root 3, this is the x component of the first force, minus a q is the second force x component. Next one is minus a by 2 q is the third force x component, it is equal to 0. X component I have made 0, otherwise you can take y component is also 0. Next, minus a by 2 q in q dash 3 root 3 is equal to a q, and a by 2 q I am sending right side, and that is like 1 plus 1 by 2 means 3 by 2 you will get 3 by 2 a q. So, this 2 will be cancelled, a will be cancelled, so that you will be leaving with q dash is equal to minus q by 3 is also cancel, minus q by root 3. This is the answer. So, if you keep in the position 4 minus q by root 3, then the charges available at the vertices of the equilateral triangle are in equilibrium. That means, the resultant force on the charges which are available at the vertices of the equilateral triangle is 0. So, with this I am concluding the Coulombs law. We have defined the Coulombs law, we have seen the respective equations, and we have solved some problems related to that one. Thank you.